Hi all, I am reassessing standard 2 and I have listed the question in the description, so let's get started. Here we consider a particle traveling in the positive x direction with a positive momentum of 8 kilograms meters per second. Then we have a constant force acting on the particle in both the x and y directions during a 0.13 second time interval. In the first part of the question, we want to find the magnitude of momentum after the 0.13 second time interval. So what I did here was break it down into the x motion and y motion separately. For the x motion, we have these values, so we can use the update momentum formula to solve for the final momentum for the x component. And that value is given here after plugging in all these values. Now we can do the same thing for the y motion, but note here that the initial momentum for the y component is just 0, so actually the change in momentum for the y component is actually equal to the final momentum for the y component. And plugging in the values here, we obtain this value for the final momentum for the y component. Now putting those two things together, we can get our final momentum vector, which is given here. And one thing to note is that the z component is still 0 since we have no forces in the z direction or momentum acting in the z direction. So now that we have that vector for final momentum, we can find the magnitude, which is given by the square root of the squares of each of the components. So we have all that, and we get this value 7.12 kilograms meters per second. Now, the second part of the question, we want to know what the position is after 5.0 microseconds. So we're going to have to use the update position formula, which is given here. Two things to note here are that the initial position is 0, 0, 0, so the final position is just given by this. And this right here is actually our average velocity, but it really isn't our average velocity, but we can use it. It's a good enough approximation because our time interval is so small and we're dealing with constant forces, so that's why we can use that final momentum over the mass. So we use that and we obtain this right here, and then we have to multiply it by our change in time, and I had to convert the 5.0 microseconds into seconds, which is given by that value. So you have, this is your average velocity, and it may look really large, but it's okay because particles travel really fast. So you multiply it by your small time interval, and you're going to get this final position. And once you obtain that final position, and that answers the last part of the question, and that is in meters, and then we're done.